everybody, and welcome to this session. During this session, we'll try and talk about how to make your web apps a bit more efficient, and how to introduce a bit of reactive into your apps, even if you're not really into it. But first, we always like to ask a few questions to know a bit more about you. So raise your hand if you're using Spring Boot 2.1 currently in production.
We don't see anything.
Yeah, quite a lot.
Yeah,
quite a lot,
okay.
actually.
Who's still on Spring Boot 1.5?
Oh, a few.
Okay, a few.
Its end of life is August, right? So,
just so you know.
Just so you know.
And we also want to know if those of you who've never heard of reactive programming before, they don't know what it is.
You've heard of it. If you've never used it at all in an application.
Oh yeah, that too. Okay.
Good.
Okay,
Awesome.
okay, that's good.
We'll try and bring a different perspective to it.
So we've been spending quite a lot of time for the past 3 years to tell you about those new options you have when you're building a web application with Spring Boot. So as you probably know, as of Spring Boot 2, there is a new option using Spring Web Flux and the reactive stack. So these are the two choices that you have to make now. And the purpose of this talk, we realized that by explaining those two choices, and basically that were two options, we were like really focusing with either you do this or you do that. And actually, we want to give you as much options as possible. And there's actually a third option that we are going to show you in demos today.
Yeah.
And this new option is basically, as Brian mentioned, to use your existing Spring MVC-based application and use some of the reactive features on the back end. So for that, we have a small example that we want to show.
Yeah. So you probably know about starterspring.io, so the best way to bootstrap your Spring Boot application on the internet. So when you fill the form and you click on it, you're getting a project back from that. But what we do is we collect the project request, so what you asked as a project, and we put that in an index, anonymized, so that we know what the Spring community is busy with, what you'd like to do, we see the trends. So it's giving us nice data points to figure out in which area we should invest and so on. So it's not only true for the web interface, same thing for IDs and command line curl, etc., because it's all going to the same service in the end. So this is super useful for us, and we're not using the real starterspring.io instance today, but we'll actually use something that resembles what we get. But this time, what we also do in real life is that we're looking at that index through a dashboard and trying to figure out trends and wondering what's going on and so on. So now in this example, so from now on, that's not representing reality. So in this example, what we'll do is we'll work on a dashboard application that does just that, plus looking at so the metadata, the index, so all the queries that were stored, plus two other sources of data. One is doing IP lookup to figure out, so we'd like to know if someone is abusing the service, like plugging a CI and doing a lot of creations. So we want to do reverse lookup to see what's going on. And as well, another source of data, which would be another service looking at events, like calendar events, what happened at one point in time to try and correlate things in case of like various events.
And let's imagine for this sample dashboard application that those three services, you don't control them. So they have an API you have to comply with. They are potentially not in your deployment environment, so they are remote. And there are challenges as basically trying to aggregate that data to build that dashboard UI. That's what we are going to focus on. If you miss, hopefully that's not going to happen, but if you miss one of those demos or something that's not clear and you want to get it back to, we will share at the end of the presentation a link to a GitHub repo where you can download the code. So there's basically two applications. There is one that's simulating those three services, generating random data. And there's one which represents the dashboard application. And when you start up those two apps on your laptop, you can basically replicate what we are doing here.
Yeah. And on that repository, every step of the demo is a separate commit with log messages and so on, so you can really follow by looking at the repository in case you missed it, you missed something.
So just to put outside a bit of the mystery, this is the kind of data that we get from one of the endpoints. So everything is, so the backend is running on 8081. There's a statistics endpoint where we can get trends about project generations. We also have a services called events, which gives you random events. In this case, it's not really random. I'm not sure Slack was down, but yeah, whatever. And there's also a services that gives you the top IPs. We were talking to you about the fact that the service API is fixed. So you basically have a first call where you get the top IPs, but we don't want to show that. We want to show the real name. So we need to call something that does the reverse lookup, and we can, unfortunately, only call that service one IP at a time. Right, so let's have a look to our application. Looks like this at the moment, and it's a regular Spring MVC application calling that backend on port 8081. So very quickly, we have this client using the RestTemplate and basically calling those three services, right? We were just showing you. And then there is some more involved API here.
Yeah, so we're as you can guess, we're getting the generation statistics, we're getting the top, the events, the top IPs, and so on. We're getting that like in a sequential manner, and we're wrapping all that in a stats container, and that's an object that we'll give to the template to the model, so that we can render the page that you've seen on the dashboard application with a graph and everything gathered into one place. So we're gathering all the data from several sources, shoving that into a stats container object, and rendering.
So then the container is basically used in this controller, where we basically build a model and basically passing that to a time leaf template, I believe, yeah. Which is rendering the page.
So far, it's a pretty like usual Spring MVC application using Spring Boot. Nothing special to it, and we will run into some problems, and we'd like to see how we can solve those for our application.
So one of the problems that we have at the moment with the stats service is it's basically in a blocking mode, right? So those three API calls potentially you don't need to call them one by one. You need all the data to build a container, but there is actually no requirement to first get the stats, then the events, then the top IPs. Yet in the current infrastructure using the RestTemplate, these are actually blocking the thread. And we want to show you how you can basically use an alternative solution as basically managing the thread pool yourself, doing joins and timeouts and all that mess. You don't want to do that. If you've done that, you know it's quite painful. So the third option we were talking about is basically to add some of the reactive stuff in your existing app. And the way to do that is to add the starter.
So when you add the Spring Boot starter reactive web, start with WebFlux, what you get is the required infrastructure to start a WebFlux application. So you get the server parts and the web client parts as well. But when you have both web and WebFlux starters on the class path, what we do is that we expect you to be in a case where you have a Spring MVC application and you'd like to use the web client. So that's why when you have both on the class path, it's still going to be an MVC application because MVC supports as well parts of the reactive story on endpoints. So this is where you are, Spring MVC application still, but we auto-configure a few things around the reactive story, including the web client. So that's where we can switch our RestTemplate builder by a web client. So just like we do for RestTemplate builder, which is a Spring Boot class, in Spring Boot we are auto-configuring a builder for you with all the preferences and opinions you've expressed so far, so including Jackson serialization options and so on, including customizers and the usual. So once you get that, you can build your own web client instance, and you can translate then the API calls.
The API is a bit different, but yeah, it was an opportunity for the team to actually review what we did with the RestTemplate. But the main change with this API is that using the web client does not actually return you the data, but it returns a publisher to the data.
Yeah, so a publisher is fully lazy, so nothing happens to it until you subscribe. You're actually calling and asking for the data. So right now we're describing, when you return a mono or a flux, you're describing some kind of pipeline, and nothing happens until something asks for data. Other than that, the API is pretty straightforward on the web client. I really like it. And it allows you to do what you'd expect, except you can translate single element to monos and multiple elements to fluxes. That's pretty much it.
All right, so let's not do everything because it's boring. Let me check out that. Let's check out. There we go.
OK. So once you have that, we have to take care of the other layer. So instead of getting directly the generation statistics, we are provided with a mono or a flux. So as a first step, what we can do is just calling block, which is a very bad idea if you've got a fully reactive application. But when we're in MVC, and as a first step, it's perfectly fine. It's just the equivalent of what we did actually with RestTemplate. So with this, we kind of have the perfect equivalent of what we had with RestTemplate, blocking and getting things sequentially. But we'd like to do a bit more and try and improve things with this, because with web client we can do actually more.
So one step to improve that is, rather than basically blocking on each publisher, which doesn't give you anything really, is to try to compose the data one layer up. And this method is basically doing some composition with 3 calls to three services. And for one particular one, whenever a new element is received, calling yet another one to do the reverse lookup. So the idea now is to stop blocking for each of those elements, keep the publisher, and use additional operators of Project Reactor to improve the composition.
Yeah, we want to do as much as possible in parallel, and we want to use our resources efficiently. So this is how, instead of blocking at every step, we want to compose and get all the monos, all those future values, which are not futures. It's really lazy. So getting all those and zipping them into the same container so that everything is triggered and happens at the same time in parallel. So once we have all those 3 monos, then we can compose them. So here, Stéphane is calling collect list. This is because we don't want to flux. We don't want to get the elements one by one. We want to get the full list, because that's what we need to render the whole page. So collect list is just giving you, instead of giving you elements one by one, it's giving you a mono of the list of everything.
So for the top clients, really, the pipeline, what it does is it's first calling that top IP service that will give you 10 IPs, and then we need to transform them that further. In that case, we are actually interested by doing something as soon as we can. So we don't want to build a full list of the top IPs, and once we have collected that, and we basically get a list as a mono, start actually issuing additional requests. We want to do that right away. So to do that, I'm actually going to use this call initially, which returns a flux of IPs. And for each of them, so whenever I get a new element, I want to issue a call to the lookup client.
So in that sense, we're trying to make some things happen in parallel, some other things happen in parallel, but inside some parts of it. So trying and expressing that in an imperative manner, it's super hard. You need like concurrent programming techniques and building blocks. It's really hard. If you do that in a declarative manner, you have to understand a bit the operators, but it's kind of visualizing a pipeline and multiple pipelines. And if you've played Mario a lot, like I did when I was a kid, it's kind of visual. So it's a bit like that. You plug things in with each other, and it works. It clicks.
So this is basically telling I want a flux of those IP, of those descriptors, basically. And whenever you get a new entry, just call that, basically get the object as a lambda parameter, then change it to something else, and that basically returns you a flux of that thing mapped. In the end, I'm also only interested by the list. So I can actually, on that method I've created, I can invoke collect list again.
So yeah, here we've got everything we need, and we need to zip and
so we basically need to tell Reactor, here are the 3 things that I have. I don't care how, but just get them for me. And once you have them, call me back, and I'll run some additional business logic. And there's an operator, as Brian mentioned, called zip that does that, where you can specify a bunch of publishers. So that's generation stats, events, and top clients. And there's a map method that basically gives you a callback whenever the data is available.
Yeah, so inside that tuple, you'll get all the types that you've specified before. So inside the T1 of the tuple, you'll get the stats, and the second one, you'll get the events, and so on. So from there, we can reuse our builder and just get a mono of our container in the end. So it took a couple of steps, but we've got our builder, and we'll get a mono from it in the end.
So basically what you get an object. If you pass 3 publishers, you get a tuple back with 3 accessors. If false, you get false, you get the ID. There's a limit. Do you know the limit? Because I always forget. Is it 9?
There are a few implementations with the explicit arguments, and then there's
that's 8.
The varg version.
Right, okay. So there we go.
Reasons.
So now I can basically return that stuff, and I don't need that old code we don't use that anymore. And ultimately, what that code will return is a publisher of the container, right? So you've pushed the logic one layer up.
And still, at that point, nothing happens. If you just get the mono and if you don't do anything on it, then nothing happens.
So let's make sure it does.
So here, we're calling block because our view rendering technology doesn't support reactive rendering. So just doing that will trigger subscribe and render everything at once. So here, we're way more efficient because everything happens in parallel. We're not paying the cost of the latency multiple times. So we're in a better situation. But still, problem can happen.
And we have one small thing here. It's an opportunity to show you how you can easily test that stuff. So that's a WebMVC test for the controller. I have a test here where I'm basically mocking the stat service and validate the content. So it used to return a container, now it returns a mono of container, so I need to adapt that call very easily. There we go. So far so good, except now let's make sure something weird happens.
Yep.
So on the back end, we have a latency service that's implemented as a custom actuator endpoint. So if you're interested by that, you can check out the code. And the latency endpoint basically slows down a ratio of requests, just for the purpose of the demonstration, between 200 milliseconds and 8,000 milliseconds. Right now, we can see the ratio. Well, if you can read that from the back, the ratio is at 0, that's 0, so 0%. And what I'm going to do is I'm going to change it, basically do an update on the back end, to change it to 80%.
Yeah. Basically, what we're trying to do is something that should resonate. If you ever had to call a service that's not really under your control, and sometimes the latency is just awful, and it can bring your whole system down if you don't pay attention to it. So this is basically that use case that we're trying to solve.
Wow. It's a bit slow now.
It really is.
So I remember we also had some kind of Earth indicator for the remote service, so maybe you have a look to it. Oh. So that's what you get by default with Spring Boot 2. You don't get any details, so you basically have to opt in to get more details. So let me actually do that quickly.
So we'd like to see the details of the health endpoint to see if we got more things than just up. And in our case, I believe we've built a specific health indicator to know about the reverse lookup service to see if it's up. So basically what the indicator, what that indicator is doing is just sending a query to that service, seeing if everything works out, and then saying up or down. And in our case, it's still up.
So it doesn't say much. Oh, by the way, have you noticed that the application restarted automatically? Have you noticed that?
Oh, yeah.
Quick question. Who doesn't know what Spring Boot DevTools is? Everybody know? Oh, quite a few. OK, all right. So Spring Boot DevTools is an optional module you can add to your project. What it does, basically, it's going to monitor your class path, going to monitor your project files. And it will start your application in development in a certain way, so that if you change a file, it will notice that and restart the application. It won't restart the VM process, because it couldn't, but it will restart the application context in an efficient manner, which basically allows you to do changes to a running application and get them updated automatically. So that's one thing it does. The other thing it does is it also implements a very, very basic live reload server. So that's the plugin I've added to my browser over there. You probably can't see it. I can't even see my mouse. There we go. So when you have such an application running with DevTools, you can connect your browser to the Spring Boot application. And once the application has restarted, it can request the browser to refresh.
Yeah, depending on the changes you do, if it's code related, it will restart the context. If it's just a static file, it'll just trigger the live reload on your browser, so you don't have to do it manually, and it won't restart anything in your app.
So in the IDE, there's a nice integration for it. So for instance, in IntelliJ IDE, they have this on-frame deactivation option where you can ask it to update classes and resources, so basically incrementally compile your project or copy properties files that have changed. So the experience is that you do a bunch of changes, then you switch to the browser, typically, if you're running a web app. So you're basically losing the focus on the IntelliJ window. And that will trigger an incremental compilation, which will trigger DevTools, etc.
So definitely, if you're working on Spring Boot applications and you don't have that dependency, you're really missing out, because we're really putting a lot of stuff in there to make sure that you get a nice development experience and that you don't have to wait for nothing.
So the application is still slow, though. So what should we do? The Earth indicator says up.
The problem is, if the service would be like down, when a resource is down, basically the indicators, they're useful because you know something's broken. But here, it's not broken in the sense that it doesn't work. It's broken in the sense that your customer's unhappy. And this is the difference between checking the health of your application and checking like the current status and the performance and how things are running currently. And so that's the difference between what we do with Actuator in Spring Boot and what we call observability. And those are like, you should have both and not one or the other, because it's really working at different levels.
So with Spring Boot 2, there's a new project that we've integrated, because if you've been using metrics with Spring Boot 1.5, 1.x, you know that we have an API for that we've switch over a new project called Micrometer. So one more time, sorry. Who knows about Micrometer? Okay, so that's a good chunk. Fair amount of people. So the tagline of Micrometer, for those who don't know about it, it's they say they're like SLF4j but for metrics. So they have a base API that you can use that's independent of any monitoring system, where you can define metrics and operate on them, like incrementing, decrementing values, adding meta information to the metric, etc. And for each monitoring system that Micrometer supports, and there's a lot of them, they will make sure, they will do the heavy lifting for you. So they will basically translate to the naming system of the monitoring system. They will publish the metrics to the monitoring system, etc.
The problem with metrics is that if you want to have metrics, you have to sneak into all the libraries and everything you use to add those metrics and create them at some point. The good news is that this is already done with Actuator. We've already instrumented a lot of things in the Spring ecosystem. So just having that will create a lot of metrics that you can look into. And this is part of the Spring Boot support that we're working on. So this is already done. And of course, you can add your own.
And there are also other third-party projects not related to Spring at all that have picked up Micrometer, because Micrometer is not, I mean, it's not specific to Spring, so you can use it without Spring if you wanted to. And so there are a bunch of projects that have integrated that. So if you're building with a system that uses Micrometer, like a Spring Boot app, all those metrics will be available to you as well. So if you just add the actuator, you'll get the in-memory metric endpoint, which is not very useful. It's just to make sure, I mean, to see what you have in the system, but it's not pushing data anywhere. So for the purpose of the demo today, we are going to use Prometheus. So once you've chosen a monitoring system, you need to add a registry implementation on your class path, which will do the translation I was talking about. So
back to what we're trying to achieve right now is that we know that something's not working properly in our system. We're calling several remote services. We don't know which is behaving. We don't know when, really. So it's really hard to see what's going on. So that's what we're trying to do. We're trying to build metrics, create them, and we want to look at something, a picture that tells us where the problem is really.
And because a monitoring system may have information about plenty of different applications, we want to make sure that the metrics that we are going to emit are tagged with something that helps us isolate them. So the metrics, as you'll see in a minute, they have a concept of tags, so you can add an arbitrary number of label to them if you want. So you can, for instance, add an application tag which has a given value, and it will allow you in the monitoring system itself to say, give me all the metrics whose application tag has that value, and then you'll get only the metrics for that application.
Typically, you'd say application name and maybe the instance number and maybe the region if it's deployed on a cloud environment, stuff like that. So there are tags that you can add on a per application basis, and then there are tags that are created on the fly for the metric itself. Like for an HTTP request, the tags would be about the path, the status, and so on. And the metric itself would be like the time it took to process the request.
Most monitoring systems are push-based, so when you add a registry for a monitoring system implementation, you usually have to provide your API token and a destination, and basically the implementation will start pushing metrics to the monitoring system. Prometheus is a bit different because it scraps data, so it's basically expecting your application to expose an endpoint somewhere with the Prometheus format. And depending on configuration, as you can see here, it will basically call the application every 10 seconds, 15 seconds, 20 seconds, and update the state of the application. Yeah. For this one, we have a job called Spring that every 5 seconds calls both our applications, so the backend and the dashboard. So if I start Prometheus, on the command line, it's reading for that YAML file, and it will just use that by default.
But there are problems right now because it's trying to pull data from our applications, and our applications are not responding properly. This is because we have security on the class path, and by default, it's protecting everything. So you have to configure your application accordingly. So here in our case, because we're not separating the admin parts from the public parts, this is everything's on the same port, but we can change the security configuration to tell Spring Boot to make the Prometheus endpoint public.
That should hopefully help.
So right now, Prometheus should be able to pull data from our application, and it should collect metrics.
But it's still very, very slow.
So at least we've got something recorded in our metric system of one of our incidents about the application being slow. So we might have a chance to see somewhere what caused it and what was the impact.
So let's look at Prometheus for a minute so that you can see actually the raw data, and then later will show you how you can basically show that data in a dashboard. So this is all the stuff that currently Prometheus records. There's also some Prometheus specific metrics that are not recorded by the Spring Boot application, but all the rest is. And something we would be interested in is to look at the max time for server requests. And one in particular, which is, let me see, this one, which is our basically endpoint we've been working on. So you can see all the tags being added. So the application tag, there is also an instance. The name of the job, the name of the job is the thing in the YAML we had. And we can see that the max is almost 8 seconds.
Rings a bell, right?
Yeah.
The good thing with the tags is that you don't have to get like very broad metrics. You can ask for a specific, like give me the 90 percentile of get requests on that path with with the HTTP status 200. So you can really like drill down and see what's going on and really know about a specific cases and have a clear picture of what's going on. So by default, we have that dashboard. So if you're getting Grafana and getting the default dashboard for Spring Boot.
So that's quite interesting that you basically get that managed for you out of the box, and you can add your own. So we've prepared a dashboard with a bit more data. I need to take the right name here. And then we can see the max, but in this case, this is not the max for the server, but it's the max for the HTTP client request the server is issuing. So it's basically what we are doing with the web client. And the key piece here is to remember when we've explained there is a RestTemplate builder and a web client builder that's auto-configured by Spring Boot. It's quite important to use those bits if you're interested by a consistent developer experience.
Yeah, we're not only configuring the message converters and codecs for Jackson and so on, but we're also instrumenting things on the fly. So it's not just about like the features you get from it. It's about also the important DevOps stuff you can get out of it.
So the max time for those in the back and probably in the middle of the room, the max for the free reverse lookup is 7.8 seconds. So we can now clearly see that our free DNS lookup is the culprit. So that's the thing that we call to get the name from the IP.
Yeah.
So what can we do to fix that? Because something we didn't mention is that we actually, in this demo, we have 2 reverse lookup. There is a free one, and there is one where we have to pay per call. Of course, you don't want to call that if everything is all right. But if you want to provide a decent user experience to your users, maybe at some point you may have to fall back to the costly option.
Yeah. So the easy solution in an imperative manner would be to go, okay, I'm going to go through the paying version every time, and this might cost you a lot of money. But here, like Stéphane said, because we control a bit the time and how things are processed and how things evolve over time, we can do more fine-grained things with the way we're collecting data.
So now that we have this pipeline that where we basically zip those 3 things, and we have access to reactive operators, we can very easily improve that pipeline with something that doesn't know about HTTP, but can provide you very interesting features for free. So what we want to do is back to this method there where we do the free reverse lookup on this publisher. So at that point, the operator itself doesn't know about anything about the implementation, right? So it's a publisher of a reverse lookup descriptor. What we would like to do is we would like to wrap it and say, wait, if I didn't hear from you within, let's say, 500 milliseconds, just cancel, give up, and I will tell you what to do next. And for that, there is an operator in Project Reactor called timeout. I probably need to use
So
here.
with timeout, you can give it, there are several variants for that one, including the simple one, which gives you, where you give the duration, the actual expected timeout that you want to enforce, and the backup solution. So either a default value, or in our case, an alternate publisher, something else that will provide the expected thing that we wanted to have in the first place. So here, it's a concise and nice way to say, try the free version. If it doesn't work out in the amount of time that I've configured, just switch to the other one, and things will go better. And if we try and do that, we kind of notice that we don't have the performance problem anymore. But like, you shouldn't trust us. We should take a look at our dashboard to see what's going on.
So we need to wait a bit because the scale went from 8 seconds to 500.
Yeah,
so.
right.
All right, let's send a bit more traffic.
So what's expected here is that we'd like to see like the good cases where everything goes very well and the response times should be very low, and we'd like to see the worst case scenario being like near or around the timeout that we've configured, so that we don't really go over that time and the experience doesn't suck for our users.
It's here in the bottom actually somewhere. I can't see the difference, but oh yeah, the free one went 222 milliseconds stop. Wow, okay. I'm sure we can, oh, that's the wrong thing. So we can manage to get a bit more.
Okay, so
not really.
We're instrumenting a lot of things with WebClient, RestTemplate, the MVC, Spring MVC, WebFlux frameworks, and a lot of things, again, in the Spring ecosystem. So you can build a lot of dashboards and keep an eye on interesting things in your application. And this is the difference between like not knowing what's happening and having just the health indicator telling you that something works, and really knowing what's going on and having the tools to really tweak the experience and know where you're spending your time and resources.
So we've had more data now with the latency thing, and you can see now that the max is almost 300 milliseconds, because everything that's above 500 is basically a no-go. And below here, we're talking to you about tags. We can also we can also create a dashboard for two URIs, one on top of each other. So this is the number of operations of the costly service in green, and the yellow one is the free. I know the color should probably reverse, but whatever. And you can see that as soon as the biggest the tolerance is, so if you accept maybe, I don't know, 2 second stop, then you'll see the free service number of operation raising, and on the other way around. So it's actually very easy to design those dashboards with the existing capabilities that Micrometer provides.
All right, so now we've solved our performance problem in a way that wasn't obvious to do with RestTemplate if we had that problem. But we can do even more with the web clients, things that are even impossible to do with RestTemplate, actually.
All right. You want to show that, or you want to show the properties? We have 10 minutes.
Properties? Let's do it.
You try both?
Yeah.
Okay, so very quickly, what we want to show you is nothing really related to performance, but this is something that we've seen many times, people not being really aware of. And showing you how you can basically design a configuration structure for your application keys, application configuration keys, and reuse the same features that what we are using internally in the Spring Boot team. So rather than hard coding that 500 milliseconds there, what I would like to do is to be able to expose a configuration key and basically be able to reuse that without bothering where that's coming from. So how the value has been bound, basically.
Yeah, and binding to an add value attribute doesn't count as doing something.
Yeah, don't do that.
It's actually easier to do it with properties. It's just a POJO, and you test. You don't have to mess up with the environment. You can easily add rich types like duration and bind to it from the environment. You can get a per environment property with your application properties file. You can even add validation rules on your properties, so that if you've got like complex keys that should look like a regex or something, you can add validation rules on it. So it's really rich. It gives you documentation. It gives you you're getting help from the IDE, and you're getting help from Spring Boot itself. So it's really easy, and usually it's the best course of action.
So basically what we have now is a very simple properties type, where we're basically asking Spring Boot to bind keys that start with dashboard. So if you find a key called dashboard.timeout, then it will basically call the setter with a value, right? It's registered as a component now, which means it's a bean. So I can go ahead on my stats service, where I have the value over here, and replace that with this timeout, which I need to inject somewhere. So let's do it here.
And since it's a regular component, you can inject it in the constructor of your service class, and that will work.
But the interesting thing is, if you look at that code doesn't know anything about how it was bound, if it's something coming from the environment. It's just a data structure that basically describes your configuration, and describes also the sub namespace or subgroups that your configuration may have. In this very simple case, there's a single property, but you can add like inner classes if you want to structure the keys a bit more. But as a consumer of that object, I don't need to care about where that's coming from. Right, so what did we say again? Dashboard, timeout. Let's say 4 seconds, something like that.
Not really helpful here.
Yeah, let's try to be helpful.
Auto-completion in the IDE.
Oh yeah, we don't have that, but I just want to show that actually it's taking more time now. There we go.
Yeah, there you go.
So okay, we're back to a crappy situation, which proves that basically that works. So let's move it to 100 milliseconds. And that's much faster.
Better.
Okay, so this is how you can basically very easily expose those keys. The problem is, as Brian mentioned, the IDE is not so happy about it because it doesn't know your key, right? So it can't basically help you. It can't give you auto-completion assistance. It can't validate the value. So you can put something like this, and the application for sure won't restart if you do that. So there's a very easy way to get the same user experience by adding an extra step to your build, which is what we are going to do now.
So if you add a nice dependency, which is an annotation processor, when your application is being compiled, it will create a metadata file with your classes, and this will be picked up by your IDE, and this will be picked up by various tools. So this is just a JSON format that the Spring Boot team has defined, and this will be picked up by things including your favorite IDE. So you can get support and auto-completion in your IDE, default value, documentation. If there's validation, it'll tell you something goes wrong. So yeah, really helpful.
I'm sad. Whatever. All right, so yeah, let's go maybe with one more trick with the web client. We have 5 minutes.
Yeah, let's go. So the thing you can do with Flux, it's just way more than just an asynchronous collection. It's actually a stream of data. You're getting elements as they come. So far, we've used it as an asynchronous list. But here, what we'd like to do is, let's say we have an endpoint on our service where we are collecting the statistics, and we have an endpoint where we can know real-time the number of projects that are being created on start.spring.io. So the thing we'd like to have is have a dashboard that's a bit fancier and collect that data in real time.
Should I show that then? Okay. And then we can show how we make that happen? Okay.
Yeah. So this is what's happening. So right now, the browser is connecting to our dashboard application through an SSC endpoint, so server-side events, server-sent events. And if you look into your network tab, you can see the actual events being sent to your browser. But the trick is, it's not polling done from the dashboard to the other remote service. It's an actual persistent connection being shared amongst all the browsers looking at that dashboard. So you're getting the event, and each event is being broadcasted to all the consumers, and that data is being just written to all the browsers listening to what's happening. So it's really efficient, and it's not really requiring a lot of work or thoughts. It's just, here's a flux, and a Spring MVC knows how to deal with them in that manner, and it knows that a flux can be written as a stream of data, and it's written as a server-send event stream here.
So basically what we have is, we have this backend sending JSON stream, Brian just explained. On the main application, the dashboard application, we've added a new method that basically returns a flux, so it doesn't do anything, like just streaming whatever comes. And there's an extra, two extra operators added to that flux. One is share, which will do the unique HTTP connection Brian just mentioned. And there's also a cache operator, so that if you reset, you basically get the last 20 items that we knew about. So that's basically when you refresh here, we get the last 20 we knew.
You're not starting over.
This is stored, so this publisher is stored as a field, so you're not creating that pipeline every time again, because that's the purpose of the caching, right? So you have a definition, and whoever is actually asking for it will get the same publisher instance. So this is what we return here, which basically represents the stream of data. And the next step is to send that to the browser using SSC, and it's as easy as just returning that and with the proper meta type. So if we go to live stream on our backend, this is basically what the browser sees. And then on the client side, what you do is you create a new endpoint using the JavaScript API and just call that.
So it's using servlet async processing, but it's not using async IO. So that's really the difference between doing that with MVC and that with WebFlux. With MVC, you're dealing with things asynchronously. It's just like adding @async on a controller method, but you still have to deal with one thread per request and so on. So it's still consuming more resources than doing the same thing with WebFlux. So that's the difference. But still, functionally, you get the same feature for users. So that's pretty much what we wanted to show.
So I think
we've got 1 minute.
20 seconds. And everybody wants to have lunch, I'm sure.
Yeah, we're the last hurdle between you and, and food.
Before the line starts, we probably need to wrap it up.
All right.
All right, thank you very much. Enjoy the rest of the conference.
The link.
I'll the link.
Many thanks to Brian.